Imagine standing at the edge of everything that has ever existed. Every galaxy, every star, every atom, all of it behind you. And in front of you, nothing. Or maybe something far stranger than nothing. Because here is the question that has haunted physicists and philosophers for centuries. If the Big Bang created the universe, what was there before it happened? The answer might be that the question itself is broken. And that is where things get really interesting. When scientists trace the universe backward, pulling galaxies together, reversing expansion, winding the clock back, everything converges on a single moment. Approximately 13.8 billion years ago. At that point, all the matter and energy in the observable universe was compressed into a space smaller than an atom. Smaller than a proton, possibly a single mathematical point with no size at all. Temperature and density become infinite. Or at least, they become numbers our physics cannot handle. And then the equations break. Not because something magical happens, but because the tools we use to describe reality, the laws of physics as we understand them, stop working at that boundary. It is called the Planck epoch, the wall before which our models return nothing useful. So when we ask what came before the Big Bang, we are really asking what was on the other side of a wall our best theories cannot see through. Let us look at what some of the smartest minds on Earth have proposed. Here is an idea that sounds simple but is quietly devastating. Stephen Hawking and James Hartle proposed something called the no-boundary proposal. The idea goes roughly like this. We think of time as a line, stretching infinitely in both directions. Past on one side, future on the other. And the Big Bang sits somewhere on that line with a before and an after. But what if time is not a line? What if time is more like the surface of a sphere? Think about the surface of the Earth. You can walk north. You can walk north further. You can keep walking north, but eventually you reach the North Pole. And there, the question, what is north of the North Pole, stops making sense. There is no north of the North Pole. North simply ends. Hawking suggested that time might work the same way near the Big Bang. As you go further and further back, time itself smooths out and closes. There is no edge, no wall, just a curved surface that has no before the same way the North Pole has no north. In this model, asking what came before the Big Bang is like asking what is south of the South Pole. The question is not unanswerable. It is the wrong question entirely. But not everyone is satisfied with that. Some physicists think something did come before, and the universe we live in might be proof of it. What if the Big Bang was not a beginning at all? What if it was a bounce? This is the idea behind cyclic cosmology. The proposal that the universe does not just expand once. It expands, slows, contracts, collapses back down to an almost infinite density, and then explodes outward again. A new Big Bang. A new universe. Over and over, perhaps forever. In this picture, before the Big Bang is simply the previous cycle. The universe that collapsed before ours did. One version of this is the ekpyrotic model, a theory involving extra dimensions where our universe is a kind of membrane, and the Big Bang happened when two of these membranes collided. Another version comes from loop quantum cosmology, where the quantum nature of space-time prevents a true singularity. Instead of collapsing to a point, the universe bounces, like a spring that compresses but never quite reaches zero. In these models, time stretches back further than our Big Bang. Our universe had a parent, and that parent may have had a parent before it. A potentially infinite chain of universes, each born from the death of the last. But there is another possibility, one that does not involve a chain at all, but something closer to an infinite ocean. Most cosmologists today accept that the very early universe went through a period of extremely rapid expansion called inflation. In a tiny fraction of a second, we are talking timescales so short they barely have names. The universe inflated by an enormous factor, smoothing out irregularities and setting up the large-scale structure we see today. Now here is the strange part. Some versions of inflation, called eternal inflation, suggest that once inflation starts, it never fully stops. Quantum fluctuations keep driving inflation in different regions of space, while other regions, like ours, drop out of inflation and become normal expanding universes. In this picture, our Big Bang was not the beginning of everything, It was just a local event. One bubble nucleating in a vast, possibly infinite sea of inflating space. And in that sea, other bubbles are forming all the time. Other universes, each with potentially different physical laws, different constants, different histories. The multiverse. In this model, before the Big Bang is a different region of that eternal inflating space, a region that never stopped inflating, that has no beginning we can point to, that may simply have always been. Always. In some form. Inflating, that word, always, is where the real philosophical weight lives. Every theory we have looked at so far starts with something. A previous universe, an inflating space, a no-boundary quantum geometry. But what about nothing? True nothing, not dark, empty space. Space is something. Not a quantum vacuum. A quantum vacuum seethes with virtual particles and energy fluctuations. True nothing, no space, no time, no energy, no laws of physics. Here is what makes this so difficult. If there was truly nothing, not even the laws of physics, then there is no mechanism to explain why something appeared. Laws of physics describe what matter and energy do, but if you have no matter, no energy, and no laws, you have no reason for anything to happen. And yet, here we are. Some philosophers argue that true nothing is actually unstable, that something has to exist. Because nothing is in some sense impossible, that existence is logically prior to non-existence. Some physicists argue that the universe could have arisen from a quantum fluctuation. But even a quantum fluctuation requires quantum rules, which means it requires something. The honest answer here is that nobody knows. Nobody has a complete mathematically rigorous theory of how existence began from non-existence. It may be the deepest question in all of science. And that brings us back to the question we started with. Let us close the loop. What was there before the Big Bang? If Hawking and Hartle are right, nothing was there before because there was no before. Time itself began at the Big Bang, the same way the North Pole has no north. If cyclic cosmology is right, another universe was there before. Older, perhaps unrecognizable, collapsing toward the point that became our beginning. If eternal inflation is right, our Big Bang was not the start of everything, just a local event in an infinite, always inflating space that may have no beginning at all. And if the honest answer is the right answer, we do not know. Our physics hits a wall at the Planck scale. What is beyond that wall may require a theory we have not yet built. A marriage of quantum mechanics and general relativity that nobody has fully written down yet. What we do know is this: the fact that we can ask the question at all, the fact that matter arranged itself into brains capable of wondering about its own origin, is already one of the most astonishing things in the universe. Whatever came before, it led to this. To you, sitting here, wondering about the edge of everything. And that is not nothing. If questions like this keep you up at night, you are in exactly the right place. Subscribe, and every week we will go a little further into the deep end together. Next time, the universe is not just expanding, it is accelerating. Something is pushing it apart faster and faster, and we have no idea what it is. We call it dark energy, and it makes up most of everything that exists.